Today we are on FRQ topic number 6. I call this function analysis. I used to call this miscellaneous, but I've changed my mind. I'm going to call it function analysis. Most often you're given a function, there might be a situation involved, or it might just be some function. It might be given you as a table, a graph, an equation, but then you're just asked random things to do with that function. Okay? All right. Before I go much further, if they give you a function with absolute values in it, immediately make it a piecewise function. That will help you throughout it. Alrighty? Okay. Let's see. These questions usually allow AP to determine if you know concepts like continuity, differentiability, if you know how to find derivatives, integrals, using proper notation, proper work. Do not do computations in your head. Communicate everything that you do. And they can ask you anything, so don't be rattled. Just do what they ask you to do. Don't forget your derivative rules. Okay. Finding local extrema, relative extrema, or integrating interesting integrals. Okay, if they ask you that, chances are on the BC exam you're going to be using some of our by parts, partial fractions, some improper integrals, our BC only integration techniques. Don't forget the average value of a function formula. They might ask you that. Average rate of change, equation of a tangent line. I've seen that several times to approximate another value of the function. Euler's method too. That goes along with equations of tangent lines. Euler's method would be equation of a tangent line with 2 steps or more. Okay, and finding the limit. If you are asked to find the limit, quite often probably it will be L'Hopital's rule. So remember that you need to show these two limits individually. Limit of the top, limit of the bottom, individually to earn full credit. Okay? And then you can apply L'Hopital's rule. Okay, so just random things. Random things. So just do what they ask you to do. All right. We're going to take a look at the FRQ in this topic from 2024. This was a pretty high scoring problem, so the kids did really well on this overall. Okay, the function f is twice differentiable for all x, and f of 0 is 0. Okay, values, that's probably going to come into play. I might highlight that a little bit. Okay, values of f prime, the derivative of f, are given in the table, so f prime is in the table. For x greater than or equal to 0, h is defined by this integral. Find the value of h prime of pi and show the work that leads to your answer. So in part A here, we are given that h of x is the integral 0 to x of this square root. Oh, there's a t there. Okay, and they ask us to find h prime at pi. We must show h prime of x first, and then plug in pi. Do not plug in pi from the get-go. When you take a derivative at a point, you first take the derivative, then you plug in the point, right? So first take the derivative. The derivative of an integral, this is applying the second part of the fundamental theorem. We start at the top boundary, it's the derivative of this integral, plug in x for t, and then multiply by the derivative of x, so that's just 1. Like that, minus, and then you're plugging in the bottom boundary, but the bottom boundary is 0, and when you take the derivative of a constant, the second part is going to be 0. So essentially, It is just the integrand with x in for t. Do not put a t here, because then you did not use the second part of the fundamental theorem. And h prime of x is going to have x's in it, not t's. All right? So put the x in for your t. All right, now it's time to plug in pi for x. Okay, and now we go to our table, because our table has f prime of x and there's pi, so 6 is f prime of pi. So I'm going to write this as the square root of 1 plus 6 squared, and I will say stop right there. This line is not a safe stop spot. You cannot safe stop there. There is no scientific calculator that will evaluate this for you with an F in there. So no, you can't safe stop there. This part was worth 2 points. 1 point was for the fundamental theorem, FTC, the second part of the FTC, and then 1 point was for the answer. And you guys, when I say the answer, that means the answer is right or wrong. Okay? If you made a mistake along the way but got an answer, that does not give you this answer point. Okay? All right. And they did make a note that on this, to earn the first point, you must show the h prime of x with x's in it before you plug in the pi. All right? Okay. Okay, part B. Okay, what information does this integral provide about the graph of f? What is the meaning of this integral? So we must recognize that this is our arc length formula. This is our length of f formula. So this gives the length of f from 0 to pi. That's what that does. So h of x gives the length of f from 0 to pi. I might even say from x equals 0 to pi. This was worth 2 points. 1 point for saying something about the length of f, and 1 point for the interval, 0 to pi. All right. So doing pretty good so far. Let's go on to part C. Use Euler's method, starting at x equals 0 with 2 steps of equal size to approximate f of 2 pi. So Euler's method, 2 steps equal sides. This will be our answer. We're starting at x is 0, so I'm starting with the point that they gave me. So I like to show this as we're starting at 0, 0. We're going to have 2 steps. Okay, we're ending when x is 2 pi. Therefore, our middle step must be when x is pi. And this y value will be our answer. What is our change in x each time? Our change in x is pi. And then we have 2 point slope steps. So the first point is 0, 0. The first slope is f prime at 0. F prime at 0. And we go to our table for that. F prime of 0 is 5. So the first equation would be y minus the y coordinate of our point is equal to the slope times x minus the x coordinate of our point. But in Euler's method, the new x is pi. So in Euler's method, this will always be our change in x. So that will be a pi there. Okay? Pi minus 0. So we get y is equal to 5 pi. So now we know that our first intermediate y value is 5 pi. So we go to our second step. The next point is pi, 5 pi. Slope is f prime at pi. I'm going to go to our table for that. F prime of pi is 6. And so now for our equation, y minus the y-coordinate of our point is equal to the slope times x minus the x-coordinate of our point. That would be our new x minus our old x. That's always going to be your delta x there. So y is equal to 6 pi plus 5 pi, or 11 pi. So that is our approximation for f at 2 pi. How was this scored? They gave 2 points for this. 1 point was for showing Euler's method with 2 steps. And they made a note on this that said at most 1 error in your steps. Okay? And the second was for the answer. And the answer is right or wrong. Is this there or not? Okay? So if you made an error in this step, there's no way to earn the second point. And part D, find this integral. So this integral has nothing to do with f, does it? It's just evaluating an integral. And it's an indefinite integral, so we'll have a plus c at the end. Alrighty. T plus 5 cosine t over 4 dt. This is definitely a biparts integral. So this was definitely a BC only FRQ. So by parts, I'm going to create my table. My u is going to be t plus 5. My dv is going to be everything else. I take the derivative of my u until I get down to 0. The first derivative is 1, the next derivative is 0. Over here I take the integral. The integral of cosine is positive sine. And then we undo the derivative. The derivative would be a fourth, so we multiply by 4. The next antiderivative, the antiderivative of sine, is negative cosine. We need another multiply by 4, so it'll be a negative 16 there. And we multiply diagonally after we do plus minus, plus minus, plus minus, all the way down. So this is equal to t plus 5, put that in parentheses, otherwise you're only multiplying the 5 times this, times 4 sine of t over 4 plus 16 cosine of t over 4 plus c. Okay, how did they score this? 1 point was for knowing that you were doing by parts integration. Do you have a u and a dv? Okay. By the way, if you did not show the u and dv, if you did not show the heading of this, but you showed this process, that does clearly show that you were doing by parts. So when I say u and dv here, they made a note that said you don't actually have to have u and dv. You can show this and then the answer and get full credit. All right. The next part was for knowing what to do with the u and dv. Did you know to multiply like this? Did you know to put it together like this? And then the last part was for the answer. They made a note. To get the answer point, you must include the constant of integration to get that answer point. So that was worth 3 points. So that was the 2024 FRQ on this topic. Okay,